Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at adding and subtracting algebraic fractions. When adding and subtracting algebraic fractions, the rule is you need a common denominator, and probably the most challenging part is finding that lowest common denominator. So what we're going to do is start with an example with numerical fractions. I'll explain the process, and then we apply that same process to algebraic fractions. So if we take a look at this example, we don't have a common denominator, so we need to change these to equivalent fractions with a common denominator, and we always look for the lowest. In order to look for the lowest, you need to factor. So 24 is 3 times 8. 16 is 2 times 8. And then when I factor, I can see that I have a common factor of 8, so I don't need to repeat it in my lowest common denominator. So your lowest common denominator will be a product of all of your factors without repeating any. So I've got a 3 times an 8, that covers that 8 as well, times 2. So this should be my lowest common denominator, which is 48. That means we've found the lowest number that both 24 and 16 will divide into evenly. Then you want to change these to equivalent fractions with 48 as the denominator. I don't know if you can hear my neighbor's dog barking. With this fraction, I'm missing a factor of 2. I need to multiply numerator and denominator by 2. This fraction I need to multiply numerator and denominator by 3. So I'm going to have 10 over 48 plus 21 over 48. And once you've got a common denominator, you just add the numerators or subtract. In this case, we're adding 10 plus 21 to get 31. We look to see if we can reduce this, because you should always reduce or simplify fractions. And there's nothing that is common to divide out. So we're done. Let's now look at algebraic fractions. So your algebraic fractions mean that you have an algebraic expression in numerators or denominators or both. And in this case, I'm going to start off with just monomials in the denominator, just to get used to the idea, and then we'll move to polynomials in the denominator. So I need to find my lowest common denominator. It's basically factored for me already. So my lowest common denominator will be equivalent to, I'm going to start with the number. I have a factor of 2. Now I have a to the 1 and a squared, so I need a factor of a squared. You take the highest power of a, because that's the factor that both a squared and a will divide into evenly. I do the same thing with the b's, b squared and b, so it would be b squared would be my factor. Same thing here, c cubed, c squared, so c cubed is the factor that both c cubed and c squared divide into evenly. Now that I have my lowest common denominator, we change these to equivalent fractions with this denominator. So in the first fraction, I need a factor of 2, so I'm going to multiply by 2. I need a factor of a, so I multiply numerator and denominator by a. I have the b squared factor, I have c cubed factor. With this fraction, I have the factor of 2, I have a squared, I have b, I need b squared, so I multiply by b. I need c cubed, so I multiply by c. And whatever I multiply the denominator by, I multiply the numerator by the same thing. Clean it up. I now have a common denominator of 2, a squared, b squared, c cubed. I have a numerator of 6a minus 5bc. Don't be tempted to cancel any of these a's or b's or c's. Remember, you can only cancel them when they're factors of the whole numerator and the whole denominator. In this case, a is a factor of this term, but not of the whole numerator, so it can't be canceled. Same thing for b and c. So that's as much as we can do with that example. In this next example, we are going to have to factor our denominators, and actually we can only factor this first one. We can factor a t out, and we're left with t minus 1. So when we're finding our lowest common denominator, we start with our first fraction, and we start with the factors in that denominator. So we have t minus 1. We then look at our next fraction. It has a factor of t minus 1, which we already have. So we don't need to repeat it. So this is our lowest common denominator. So now we change each fraction to an equivalent fraction with this as our denominator. We don't need to do anything with this one because we already have the denominator. Here we're missing a factor of t. So we multiply numerator and denominator by t. Now that we have that denominator, we can combine the two fractions by adding the numerators. So 5 plus 6t over that denominator. Let's practice with this example. Let's factor all of our denominators. This is a difference of squares. And in this denominator, we can factor out a 3. Now, when we take a look at our denominators, or our factors in our denominators, we notice that these are almost the same, they're just different in sign. I want to make them the same. So what I'm going to do is I'm going to take that second fraction and multiply the denominator by -1, which means I do the same thing to the numerator. And when I do that, that changes it to b minus 1. Negative times a negative, or plus a negative, makes it a positive. And when I multiply that -1 to 1 minus b, it becomes negative b plus 1, which I will write as b minus 1. Now this is better for us to find our lowest common denominator, which will be 3 times b plus 1 times b minus 1. I'm missing a factor of 3 in this fraction, and I'm missing a factor of b plus 1 in this denominator. So now that I have a common denominator for both fractions, I can combine the numerators by adding them. So I'm going to have 3 plus, I'm going to distribute that 5b plus 5, and then I'm going to add like terms. So I'm going to put 5b first. 3 plus 5 is 8 over this denominator. I want you to be careful. If you would have written that as 3 plus 5 times b plus 1 over that denominator, that would be correct, but what I find is that a lot of students then are tempted to cancel that b plus 1 because they think, well, it's in brackets there, it's in brackets there, I can do it. No, you cannot, because it's in brackets, but it's in a term, and you cannot cancel a factor in a term with a factor of the denominator. So you have to expand that. That's partially, it's called partially factored, where part of it's factored, but not the whole expression, not the whole numerator. So I kind of try to avoid that and get rid of all my grouping symbols in my numerator so that you don't make that mistake. Let's look at another example. Let's look at this example, and before we start, I just want to mention that when you're doing your factoring, remember you're only factoring denominators. Don't factor your numerators because you're going to have to expand them when you combine your fractions. So just look at factoring denominators. I have two trinomials. I talked about how to factor these trinomials in a previous video. I'm not going to explain it in this video, but if you get lost, go review factoring trinomials and then come back and take a look at this so that you understand what we're doing in this example. So my factors are going to be t minus 3 and t plus 2. My factors here will be t plus 2 and t minus 1. Now that I have my denominators totally factored, I find my lowest common denominator by combining all of my factors. So it'll be t minus 3, t plus 2, that covers that factor, that factor, that factor, and then t minus 1. So I need a factor of t minus 1 on this fraction. And on this fraction, I'm missing a factor of t minus 3. Now I should have the same denominator for both fractions, so I can combine these numerators over this common denominator. And again, I'm going to FOIL or multiply this out instead of writing it in factored form, because if you keep it in factored form, you're going to be tempted to start canceling things that you shouldn't be canceling. So let's just multiply it out. I'm just doing multiplying polynomials. So that will give me t squared minus t plus 5t will give me plus 4t minus 5 minus, I'm subtracting this whole numerator, so I'm going to put it in brackets, and I'll have t squared minus 3t plus 1t will be minus 2t minus 3. My next step, I'm going to now apply this negative or this subtraction to every term. So I'm going to have t squared plus 4t minus 5 minus t squared plus 2t plus 3 over this denominator. You can't touch those terms while they have a grouping symbol around them. So in order to get rid of it, you have to distribute whatever the operation is. In this case, it's multiplying by -1. Now we combine like terms. So I have t squared minus t squared, it's gone. I have 4t plus 2t, which is 6t. Minus 5 plus 3 is minus 2. And I could factor out a 2 and I'll be left with 3t minus 1, but it really doesn't allow me to cancel any common factors, so I would leave it like this. If you want to factor your numerator, that's okay. That concludes adding and subtracting algebraic fractions. Practice, make sure you understand the concept and make sure you know how to apply it, and you should now be able to add, subtract, multiply, and divide algebraic fractions. So take care and see you on the next video.